going to talk about building rational functions and specifically writing equations of rational functions today. And I want to go back to this chart, but by the way, for those of you watching the video, the smart board is being temperamental, and that's why the screen size is a little bit wacky here. I don't know if you'll be able to adjust that on the video or not. It might be a little bit smaller. But one last plea to you, if you haven't sat down and committed these three to memory. When you have a bottom heavy fraction, you're going to have a horizontal asymptote at y equals 0. If it's the same degree on the top and the bottom, then you're going to have y equals the coefficient from the highest degree on the top over the coefficient of the highest degree on the bottom. Y equals a over b. And then we will have an oblique if we have a top heavy function by a degree of 1. So I want to put that in our memories one more time as we look at this. I'm not going to spend my time on the sketch. I want to spend my time on writing the equation. And typically what happens here, or what we're given in problem number 1, is we're given that we have a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. And we want to write a rational function that meets all this given criteria. And again, I'm going to skip the draw a sketch because I want to focus on writing the equation. And where we usually start when we work with these problems is the vertical. So in this case, what it says is x equals 0. Well, where that came from was the denominator. And since x equals 0, we just need to put x. But the other part of this problem is that we're given a horizontal asymptote. And when we're given a horizontal asymptote, in this case it's y equals 0, what we need to know about this one is that we're working with a bottom heavy. And bottom heavy means that the degree on the bottom needs to be bigger than the degree on the top. And since this is x to the first on the bottom, all that I put on top is 1. Now, that's probably a little bit wacky when you see that for the first time. So let's look at problem number 2. We've got this horizontal asymptote at y equals 0 again, and we've got a vertical asymptote at x equals 5. But when we write these equations, let's look at it starting with the vertical. And it's x equals 5, and since this equals a number now instead of 0 like the last time, what we can do is we can take 5 and subtract it from both sides to move it over here, and we have x minus 5. And that will give us the value that we're going to put in the denominator of our function. But like problem number 1, y equals 0 is our horizontal, which we just said means a bottom heavy function. So we need to have a degree that's less in the numerator in the top of the fraction than what we have in the bottom. Since this is x to the first here in the bottom, we don't need to have a variable in the top to meet that criteria. But it goes back, do you know the rules? And let's skip number 3 and move to number 4. But in this particular case now, we've got the vertical asymptote of x equals 1, horizontal of y equals 2, a little bit different here to work with. But let's start with the vertical. And some of you can look at this and you can automatically go ahead and put in what goes in the denominator. But if you can't, move the 1 over to the other side and get x minus 1. And that's what's going to go here in our denominator, x minus 1. But this time, the difference is that we have y equals 2. We have a value other than 0 for a horizontal asymptote. And where that's going to come from is the fact that we have the same degree. So that goes back to the middle column on your chart, which, by the way, is not on this paper. But you can look back in your notes if you need it. But when we have the same degree, what's going to happen is we can put an x there because it was x to the first in the bottom, so that gives us x to the first in the top. There's the same degree. But when we have the same degree, it's the ratio of the highest degree term, it's the number in front of the highest degree term on top divided by the number of in front of the highest degree term on the bottom. In other words, what we can do is we can put this 2 in front of that x, and then our a would be 2, and our b would be 1, and we would satisfy the criteria that we're given of the horizontal of y equals 2 and the vertical of x equals 1. Let's go to problem number 5. As we flip over a paper and look at 5, and I know that I haven't skipped very many, but if we look at problem number 5, and actually I do want to go to problem number 6, because, no, let's do 5 since we're here. But what we have this time is we have 2 vertical asymptotes, and we have a horizontal asymptote at y equals 1. So just because we have 2 doesn't mean that the procedure is any different from beforehand. We can move the 4 over, and we get x minus 4. We can move the 3 over and get x plus 3. And those are 2 values that are going to go into the denominator of our function. So it's going to be x minus 4 times x plus 3. But once again, like problem number 4, we have a value other than 0 for a horizontal asymptote. We have y equals 1. So what we first need to figure out is that we're working with a same degree. Again, that's the middle column of our chart. So we need to have the same degree on the top of this fraction as we have in the bottom. Well, what is the degree of the denominator, the bottom of this fraction? And if you think about it, if we multiply these out, we'd get x times x, which is x squared. So what's going to go in the top is going to be an x squared. And now that we have the same degree, it's going to be y equals 1. You don't necessarily have to write this one, I'm going to. But it's the ratio y equals a over b. A is 1 on the top. And then the coefficient on x squared on the bottom is also 1. Problem number 6. Y equals negative 2. X equals 6. And we have a hole. We have removable discontinuity on this problem. So now it starts to get a little bit more interesting. But what happens when we're solving a problem? How do we get that hole? We have to cancel something. So when we start this process, we can do our vertical just like we've been doing. So we can take our x equals 6 and we can subtract 6 from both sides. So we get x minus 6. So that's going to be down here in the denominator. But we're going to have a hole when x equals 3. So we're going to do the same process here with our whole, which is to subtract 3 from both sides, and we get x minus 3. But you just told me, when we have a whole, the process has been that we're canceling that value out. So since we have x minus 3 in the denominator, we're also going to have an x minus 3 in the numerator. And those would cancel out, but we're trying to come up with the equation this time, working backwards. And then lastly, what we have is we have y equals negative 2. Well, third in a row here, where we're going to have the same degree. As we take a closer look at our denominator, we have x times x. That value is going to be an x squared. So we need to have an x squared on top because it needs to be the same degree on the top and on the bottom. So let's put an x in front of here. X times x is x squared. And then our ratio here, y equals a over b, is going to be negative 2 over 1. Number 9. Sorry, let's go back to 8. OA. Oblique asymptote and a vertical. So, as always, when we start these kind of problems, let's deal with the vertical first. And we've got x equals 3. I'm going to write down here. And again, I hope that you don't even have to write this step, but there's nothing wrong if you do. Subtract the 3 from both sides. So we get the x minus 3. But in this particular problem, what we have is we have a vertical. Sorry, we have an oblique. And when we have an oblique asymptote, what we have to do is we have to do synthetic division. Because the degree on the top is going to be 1 degree more than what's on the bottom. So, let's figure out what it is with our synthetic division. Well, we see down here on the bottom, it's x minus 3, so when we're synthetically dividing, the number out front is going to be positive 3. And we know what the value is that we're going to get. We're going to get 2, which is coming from the oblique asymptote, minus 3. That's going to mean we could have a remainder, but we don't have to worry about the remainder. Well, where did that 2 come from? Well, if you think back, what happens is we had a 2 there that we always carry down. And then we're going to work backwards. 3 times 2, positive 3 times positive 2 is positive 6. And then what we need to ask ourselves is, what number plus 6 gives us negative 3? And we could write it like this. What number, n, plus 6 equals negative 3? Well, we can subtract 6 from both sides. And we get n equals negative 9. So that's going to put negative 9 up here. And remember, we need our degree to be 1 more than what we started, or what we have on the bottom. It needs to be top heavy. In this case, I should write that down. Top heavy. This is x to the first. So what did we start with? We started with an x squared. So those black numbers there are going to be 2x squared minus 9x. And by the way, we can make this a trinomial. We're going to add some number here if we want. If you want to leave it just like that, you can. But I usually add another number, and I usually add the number 5 for no obvious reason, I just picked 5. It doesn't matter. You're fine. It doesn't matter. Doesn't matter. So we look at that one more time, because that one's kind of odd. Of course, which ones are my favorite? Those will be those ones. But let's look at number 9 here to finish. Once again, we have the vertical asymptote. Can I go directly to x plus 4? Do you know where that came from? We just took the x equals the negative 4, and we added the 4 to both sides. So we get the x plus 4. Well, we have the oblique. Oblique means top heavy. So we're going to go back to our synthetic division. The first thing that we're going to do, in our denominator we have plus 4, so out here is going to be minus 4. I'm going to get rid of this just to not confuse it. We know what our answer is. It's going to be negative 1, the number in front of the x, plus 2. And we can have some remainder there. We just don't need to worry about that. And remember where the negative 1 came from. Well, when we're synthetically dividing, we always carry down that first term. Well, that's negative 4 times negative 1 is positive 4. And what we need to figure out is what plus 4 gives us 2. So if you need algebra behind it, n plus 4 equals 2. We can subtract 4 from both sides. And we get n equals negative 2. So I wish I would have written in black there, but so here's minus 2. And one last time. This is x to the first. So this was x to the second. 1 degree more than the denominator. So up here then it would be negative 1x squared minus 2x. And I usually add 5.